Problem number 4, we want to take each expression and rewrite it using a sum or difference identity. So when I look at this in letter A, I see sine of something plus something. Let's remind ourselves of those key identities. Sine of something plus something, here it is sine first cosine second plus cosine first sine second. And so I'll go ahead and apply that. Sine first cosine second plus cosine first sine second. Sine alpha cosine 2 alpha plus cosine alpha sine 2 alpha. And I don't really have any way to simplify that, so I'm finished. Letter B, I have cosine first cosine second plus sine first sine second. I'm going to use one of those identities backwards. Let's see which one I'll be using. Let's see, here it is right here. Cosine first, cosine second, plus sine first, sine second. If I use this identity backwards, it turns into cosine of first minus second. Well, that's exactly what I write then. Cosine of first, the 3b, minus second, the b. And of course, this does simplify. 3b minus b is just 2b. Cosine of 2b would be the final answer. Letter C, I do have this 2 being multiplied in the front, but then after that I have sine of first plus second, and that's the same one we used up here. So I can just follow that identity once again. Let me open a parentheses. That 2 will multiply the entire thing. So sine first, cosine second, plus cosine first, sine second. I am going to be able to clean this up a little bit because some of those pieces can be evaluated. Sine pi over 6, that's just 1/2. And cosine pi over 6, that's just root 3 over 2. Obviously, a quick 30, 60, 90 triangle picture can verify that. I have the 1, the root 3, and the 2. So sine is 1/2, cosine root 3 over 2. Then I can distribute the 2 that I have on the outside into each piece here. 2 times 1/2 would just cancel out, so I just have cosine x. And in the second multiplication, the 2's would cancel out, leaving me with root 3 sine x. Part D, tangent of 3 theta minus theta. So I need the difference identity for tangent. And here it is, tangent of alpha minus beta, tangent alpha minus tangent beta over 1 plus tangent alpha times tangent beta. And so let's fill that in. Tangent first minus tangent second over 1 plus tangent first times tangent second. Problem number 5. We want to simplify each expression. Of course, when I look at part A, I'm thinking probably the answer here is just x over 4 because sine and sine inverse tend to wipe each other out. I can double check. I'll assume x is positive. X over 4 would be a ratio, which means sine inverse x over 4 represents the angle whose sine ratio is x over 4. This angle right here. I'm being asked for the sine ratio of that angle, which obviously, according to this picture, is x over 4. So it is what we suspected. It won't quite be so easy here in part B because I have cotangent being mixed with inverse cosine. Once again, I'll assume that x is positive. Cosine inverse x stands for the angle whose cosine ratio is x over 1. That's adjacent over hypotenuse. I can get the cotangent ratio for this angle by simply finding that missing side. I would have x squared plus b squared equals 1 squared. I'm solving for b. That's the side I don't know. B squared equals 1 minus x squared, and then square root both pieces. I don't need a plus or minus in the first quadrant. This side is the square root of 1 minus x squared. There's no way to simplify that. I want the cotangent ratio. Well, tangent is opposite over adjacent, so cotangent is adjacent over the opposite. We don't rationalize unless we only have numbers, and so we are finished. Here is the final answer. Problem number 6. I have angle theta that's between 0 and pi over 2. Well, I know then that theta is in quadrant 1. What could I say about angle 2 theta? In other words, if I double my angle, can I narrow down its location? Well, the great thing about a compound inequality, which is what this is called, is that you can always multiply all three sides, so to speak, by the same number and keep a true statement. So what I'll do is I'll multiply through here by 2. That's going to make this still a 0. This middle part becomes 2 theta. And the last part, the 2's will cancel, giving me pi. So this says angle 2 theta is between 0 and pi. That would be quadrants 1 or 2. If you think about that for a minute, it makes sense. I mean, if my angle, my original angle is really small, like 1 degree or 2 degrees, if I double it, I'll still be in quadrant 1. But if my angle was closer to the 90-degree side, like 80 degrees, for example, if I double it, I'd get 160. I'd be in quadrant 2. What about the angle theta over 2? Well, this one you can probably just figure in your head, but you can also take the same approach. Simply come through here, and here's the original inequality, divide everybody by 2. In other words, multiply everything by 1/2, I guess would be another way to say that. What am I going to end up with? Now, theta over 2 will be between 0 and pi over 4. Again, it makes good sense. If your original angle is between 0 and 90 and you cut that in half, the biggest you could get then would be 45. And if theta was smaller, you'd get something even less than 45 degrees. So theta over 2 would still be in quadrant 1. Let's try this again with number 7. So now our original angle is between pi and 3 pi over 2. That's 180 and 270. That would be a quadrant 3 angle. What if I double that angle, angle 2 theta? Where might I land? Well, again, you can just come along here and multiply all these pieces by 2. That will become 2 pi on the left, 2 theta in the middle, and the 2's will cancel there at the end, leaving me with 3 pi. So 2 theta would be between 2 pi and 3 pi. Where is that? 2 pi is all the way around, so starting here, and then 3 pi is here. So it looks like you'll be either in quadrants 1 or 2. What if I cut that original angle in half? Well, then instead of multiplying all the pieces by 2, I would divide all the pieces by 2, or I would cut them all in half is another way I could say that. That's going to give me pi over 2, theta over 2 in the middle, and 3 pi over 4 here. So my cut in half angle, my theta over 2, is between pi over 2, that's right here, and 3 pi over 4, which is right here. So somewhere in this section, which is obviously in quadrant 2.